So this is the reason that there are two blocks on your front page where it says geometric series. We have two different formulas, and we had already talked about this one on Friday to get a little ahead of the game. There's not a definition box for that one, right? No. Okay, so here's our formula, and I'm going to write it bigger and bolder or zoom this or something. And that is S sub n equals a sub 1, parentheses 1 minus r to the n, parentheses over 1 minus r. And even on the bottom, some people really like to put the parentheses there, because if you're going to put it in the calculator, you have to have them, you know. And we had talked about how you might want to do part of this in your noggin and then use the calculator because there's just so much going on. So we're going to highlight the things that we have to put in. And that's going to be, we need to know n, we need to know a sub 1, we need to know r. Those are the things we're going to need to know in order to use this formula. So get those highlighted. And we had one more problem to kind of practice this with. I wanted to keep at least one for today. And after that, then we'll talk about the infinite. Oh, right next to this one, finite. The word finite. Calculators over here. Calculators over here. All right. So finite means it stops. This is when they tell us they want the first 10 terms, you know. That's when we know we're going to use this formula right here. Whenever they say just this far and not any farther, we'll use that finite formula. And we talked about how it looks horrendous. The formula just looks like a monster. But they usually give us how many we're supposed to find. They usually give us the first term, and all we have to do to find r is a little bit of division. So really, this is a hand it over to the calculator problem. So if you wanted to do this entirely on the calculator, you could. I usually don't recommend it because there's so many parentheses, it just can get really messed up easily. So we'll do this in pieces. And we had the got it left, problem 1. Kind of remind us how all this good stuff is going to get done. So this says, what is the sum of the finite geometric series? And you look at that and go, why would I use a formula for that one? Because I can see all the terms. Shouldn't I just add them together? No, and if you do that on the test, you lose points. Because this chapter, in case you haven't noticed, is all about formulas. You don't use trial and error for anything. You don't just guess. You don't just plug it into your calculator. You pick a formula. So it says this is a finite geometric series, and that gets my mind thinking. I have to use this one. That's the formula that we use for finite geometric series. Geometric series that stop. Well, I need to know how many. The good news is I can just count that. 1, 2, 3, 4, 5, 6 of them. And notice how I keep that big S sub 6, because to mathematicians that says, hey, I'm finding a sum here. The first one is negative 15. It's right there. Don't have to look anywhere special to get that. But here comes the hardest part for us, which is finding r. And all we have to do to find r is take any term and divide it by the term in front of it. So if it's tough to see, you can always do this. Just take 30 divided by negative 15, get negative 2. And sometimes the negatives mess with people's heads. So we're going to want 1 minus negative 2, important that there's parentheses there. And we said we want the first 6 terms, so this needs to be a little 6 right there. And then on the bottom, 1 minus a negative 2. Now remember, that would be atrocious to punch all that in. So if there's any math that we can do with this part right here, we're going to do that in our heads. So let's see, 1 minus a negative 2. That's 1 plus 2. That's 3. What's negative 15 divided by 3? Negative 5. And then this becomes a whole lot easier to punch into the calculator. So let's see what we get. Let me punch in all that junk. Parentheses 1 minus parentheses negative 2, parentheses 2 to the 6, parentheses, bam, 315. Now, easy enough to check, because like we said, they're all sitting right there. We could just punch them all in and make sure we get 315. But the points for the test are going to come from all of this. You know, do you know which formula to use? Did you use the formula correctly? And then like 1 point for punching it in. So as long as you've got all the work there, you should be good. Yeah. You're given the formulas, you're not given what they're for. And that's because if you do the homework, you should know which formula is for what. And I had mentioned this last week, but I know weekends sometimes some of the knowledge flows right out of our brain. So anything that has addition in it is an arithmetic formula. Any of the formulas that have a plus in them are going to be arithmetic. Notice there's no pluses anywhere in this formula. That's geometric. You know, there's only two things it can be. Either it's arithmetic or it's geometric. And if there's no pluses, then it's geometric. So when you look at this, you're going to say, okay, this is a sum formula here, and they're telling me there's an n. That means it cuts off. And it doesn't have any pluses, so it's geometric. Hey, that's the finite geometric series formula. That's what that's for, finding the sum. You know, you can make it work for you as long as you understand what the symbols are. So now I look at B, and B says from 1 to 10, find the sum of 5 times negative 2 to the n minus 1. And I realize, well, that's a good thing, because our geometric formulas, our geometric rule, looks like that. That's exactly what this looks like. A number in front times a number raised to the n minus 1 power. That means I can find everything I need right there from that summation. And it does say from 1 to 10. So if it's 1 to 10, that's finite. So I grab my formula. Quick reminder too, this test is worth 100 points. You want to do really well on this one. We haven't had a full test in this class since probably the beginning of this semester. We took the first test. All right, so I need to know how many. Well, it's from 1 to 10. 10 minus 1 is 9, but then you have to add 1. So that's 10 terms. Okay, so I need S sub 10. I need to know what the first term is. Well, our rule says it's whatever's sitting in front. That's the 5. Now, if it didn't look like that, what we would do is take the 1 and actually put it into the formula and see what the first term is. You get 5 anyway. That doesn't make a difference, but it's a good way to kind of double check. 1 minus. Okay. R is whatever is being raised to the n minus 1 power. Oh, that's a negative 2. And we already said we need 10 of them. And notice how we just reuse 1 minus negative 2 again. On there on the bottom. All right, the math to do in our noggin, 1 minus a negative 2. That's 3. 5 divided by 3 is not anything pretty. That's okay. We can just punch it into the calculator as 5/3. And then we've got 1 minus a negative 2 to the 10th. Now, why don't I change minus a negative to a plus there? Because this has a power. And the order of operations says you have to do that power first before you do 1 minus. So that's why we're just going to leave that to the calculator, and we're going to use parentheses like crazy and find out what the sum is. Plus parentheses 5/3, parentheses, parentheses 1 minus, parentheses negative 2, parentheses 2 to the 10th, parentheses. Boom. Negative 1,705. There it is. So sigma, which we thought was kind of scary looking for a start, is like, wait a minute, you get everything you need from those problems. You just have to look up there and say, here's a sub 1, here's r to the n minus 1, put it into the formula, 10 minus 1 plus 1, and then you have everything you absolutely need in that little sigma. So, next example here, we're going to do a part of it, not the whole thing, because the second part takes a long time. It says, and this is a very old math story, supposed to be one of those that's a myth from long ago. The soldier's reasonable request. A famous story involves a soldier who rescues his king in battle, saved his life. The king grants him any prize within reason from the riches of the kingdom, which means the guy can't say, I want to be king. That's my wish, I want to be king. No, not going to happen. The soldier asks for a chessboard with a single kernel of wheat on the first square, 2 kernels of wheat on the second square, 4, 8, and so on. Well, a chessboard has 64 squares on it. So the king thinks about this, and he's like, well, 1 kernel of wheat, and then 2, and then 4. This isn't going to amount to much. It's kind of a silly request. Sure, you can have it. Big mistake on the king's part. We're going to find out just how many kernels of wheat the soldier really got. There is an end to it, so that means it is finite. And it sounds really reasonable when you think about the fact that you're starting with just 1 kernel of wheat. Why do I keep wanting to put that in there? There we go. But you're multiplying by 2 every time. So there are 64 little squares on that chessboard. 1 kernel of wheat to start with, but we're doubling that every time. And that's going to happen 64 times. 1 minus 2, 1 to the denominator is -1. 1 divided by -1 is -1. Again, it just doesn't look too intimidating at this point. So you get to that 64 power. That's got to be a lot. Let's see how a lot that is. Oh my. It's so a lot that the calculator went to scientific notation. So let's see. We got to move that decimal place over 19 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Yeah. Of course, if this were reality, once the king figured this out, the guy would be dead because he tried to fool the king. And the emperor's new clothes story. It just, there's no way. So, in fact, the second part of this, which I said we're going to skip just because it just takes time, and it's just unit analysis stuff that you've done in your science classes before. It says that a bushel of wheat contains about 1 million kernels. Because quite frankly, if you see, okay, that's kernels of wheat are really small. I mean, how much is this really? Well, a bushel contains about 1 million kernels. The total U.S. output of wheat in the recent year was 2.1 billion bushels of wheat. And then we figure out how many years it would take the United States as a country to produce all of this wheat to fill the soldier's request. Well, it turns out it would take us 8,784 years as a country to fill that soldier's request for that wheat. So, like I said, the reality is this probably didn't happen, or if it did, the guy was soon dead once the king figured out what he'd really done to him. You don't kid a king. You just don't back in those days. All right. Little bit of word problem that's going to be geometric here. It says you are going to save money for a vacation. Excellent for you. That's what you should do. You set aside $100. Okay, it's probably going to take a little more than that. For each month thereafter, you say, you know what, I'm going to put the $100 in there, but I'm also going to put another 10%. And I'm going to try and increase this up here. And it says, how much money will you save in 12 months? Well, this is geometric because you're going to do, actually I should write this, both as percentages right now. After that first month, you're going to multiply it by 110%. So what's 110% as a decimal again? What do we use for math for that? 2 decimal places. 1.1. That's R. And this is geometric. So we want to know the sum for 12 months. We already know the first month you put $100 in there. And 1 minus 1.1 to the 12th over 1 minus 1.1. Well, 1 minus 1.1 is going to be negative 0.1. So we're going to have 100 divided by negative 0.1. That's a negative 1,000 times 1 minus 1.1 to the 12th. So what I did again was I just did this math separately. 100 divided by negative 1.1. So let's see. After 12 months, you're going to at least have $1,200 because you've been putting 100 in each month. But what else are you going to have? Oops, should have put my 12 inside my parentheses there. That was a bad mistake. There we go. $2,138 and 43 cents. You have to save a little more. If it's just you that's going, hey, that might not be a bad vacation. $2,138.43. But if you're going with somebody, you're probably going to need a little more unless you're only going for a weekend or so. So, good way to save. Now, the next part is our one last new formula. And that is, it says, what happens to a geometric sequence when r is greater than 1? All right, let's investigate this. Let's say r is 2. 2 is a nice number, and it's bigger than 1. So, I'll just start with, like, 1. And I realize that what I'm supposed to do to get the next term is multiply by 2. So I would add 2. Then I have to multiply that by 2, and then I have to multiply that by 2, and this is actually the reasonable request of the soldier here. Oops, 3 dots, not 4. If that goes on forever, can we ever find the answer? So there's always going to be another number that's bigger that we can add on, right? So when r is greater than 1, we're not going to be able to find it, but the series just keeps getting bigger. Bigger and bigger and bigger. The next part says, well, how about if your r value is between 0 and 1? Okay, well, that means a fraction between 0 and 1. I know we don't like fractions, but if you had to pick a fraction between 0 and 1, what's the nicest one to work with? A half. So, we'll start with our 1, multiply it by a half. That's going to give us a half. Then we have to multiply that by a half. That'd be 1/4. So really, we're just multiplying the denominator by 2 every time. 1/8, 1/16. 1/32, 1/64, 1/128, ... Put your fingers in front of yourself right now. Show me 1/128 of a centimeter. Get 1/128 of a centimeter. Is it hard to do? Because it has to be super tiny, right? Your fingers kind of come together at some points and you're like, oh, wait a minute, it can't be 0, but it's got to be really, really, really close. So if 1/128 is already really close to 0, are we really adding anything mathematically by adding 1 over 256? No, we're not. This is a concept we use in calculus called a limit. This is approaching 0 as a limit. It is so small, it's not mathematically significant anymore. So what happens to it? Well, it approaches 0. You don't have to take much farther in the series to get to the fact that if I can't make 1/128 show up, how am I going to make 100 or 256 show up? It's close to 0. So this process that we just saw, that's called converging. So that's a good thing. To converge is to have an R value that's between 0 and 1, a fraction between 0 and 1. It's making the numbers smaller and smaller and smaller and smaller. They are converging on 0. That we can actually find a sum for. To diverge means to go away from the group. Well, that was the first one in the green that we can't find. Diverge is what happens when R is greater than 1. It keeps getting bigger. There's nothing we can do for that. There is no answer because there will always be another bigger number to add. So we can't say, well, when I found the sum of this infinite series, I got this answer. Oh, wait a minute, I forgot to add this. You know, there would never be a way for us to finish. But because this gets closer and closer to 0, we can find the sum. And the cool thing is the shortest, sweetest little formula we're going to have all chapter. We just have to recognize, hey, if R is between 0 and 1, this is one of those special infinite series. It's an infinite geometric series. And look at that thing. That's all there is to it. S equals a sub 1 over 1 minus R. So here's the big deal. It is an infinite geometric series. And it's a teeny little formula. S equals a sub 1 over 1 minus R. So we're going to go back to that front page. And we're going to put infinite in that last little box with geometric. S equals a sub 1 over 1 minus R. And we're going to highlight the two things that we have to put in this formula. There's only two. A sub 1 and R. That's it. Very nice little formula. Hey, it's missing something. Isn't there supposed to be a little n here on all of our sum formulas? Why doesn't this one have an n? It's infinite. I suppose we could put S infinity down there, but it doesn't make any sense to do that because we don't have a last term. There is no final term. So that's how you're going to know this formula is for an infinite geometric series. Hey, there's no n here. Oh, that means it doesn't stop. It goes on forever. A sub 1 over 1 minus R. So let's see. This one says, does the series converge or diverge? If it converges, what is the sum? Well, that means the hardest part of this is that we always have to find R. You know, we have to figure out what are they using here for R. This isn't a bad one, though. Most of us could probably look up here and say, oh, they're multiplying by 1/2. But if you couldn't, you could always punch that into your calculator. Take any term, divide it by the term before it, you get 1/2. Well, that's a good thing, because that's going to get smaller and smaller and smaller. So this converges, converging on 0, and we would use our brand new little formula there. Compared to the other formulas, I always want to call this the baby formula. You know, we've got some mama bears and papa bears, but this is baby bear, definitely. And we just need to know the first term. Cool. So what? It's right here. And we already found R when we were trying to figure out if it converged or diverged. It was 1/2. Now, you could throw some parentheses on there, you could use your calculator if you want to, but I'm looking at that and saying, well, 1 minus 1/2 is 1/2. And having a 1 on top means the reciprocal. So 1/2 will become 2 over 1. Hey, the sum of this is 2. That's it. So find R. If R is a fraction between 0 and 1, then we can do it. It converges on 0. It's closer and closer to 0. Converges, think about what happens when you're driving and two cars converge. They crash, you know? But to us, that means they're coming together. And that's a good thing in math because it means it's something we can find. All right, B. Doesn't quite look like the geometric rule. And that's because they didn't start with 1. Look what they did. They're messing with their heads. They started with 0. But this is still R. R is right here. It's whatever's being raised to the power. So don't think about the negative. Think about 5/4. Is that a fraction between 0 and 1? It's not. This one is going to diverge. We're not going to be able to find it. You're multiplying by a number that's bigger than 1. You're going to keep getting bigger and bigger numbers. This diverges. Can't find it. They have to converge in order for us to find it. They have to get closer and closer to 0. Alrighty, let's look at this one. Does the infinite series converge or diverge? If it converges, what is the sum? Just like we were doing before. Okay. How are we going to find R? So we know. How do you do that? Find a couple to divide, right? I mean, they're fractions, so nobody's going to be real happy about that. But let's go ahead and punch in 3/4 divided by 1/2. And let the calculator give that back to us as an R value. If we don't want to do it by hand. Of course, you could always multiply by the reciprocal and do it by hand. But I know the fraction thing sometimes freaks people out. And I don't want anybody to be freaked out. Math number 1. Bingo. 3/2. Is that a fraction between 0 and 1? Then this diverges and we can't do it. It's going to keep getting bigger and bigger and bigger. Has to be a fraction between 0 and 1. Doesn't matter if it's positive or negative. The numbers, the numerical value has to be between 0 and -1. Can we see R on B? Or should we punch it in? Do you see what they're multiplying by? Then let's find it with the calculator. -1/9 divided by 1/3. Let's see if this is going to be a number between 0 and 1. So it's a -1/3. Well, look at the negative. Is 1/3 a fraction between 0 and 1? We can do this one. This converges. So we grab our new little baby formula here. And all we need is the first term. Well, it's right up there. 1/3. And we're going to divide that by 1 minus whatever we got for R. Well, that was -1/3. And again, if you don't like working with fractions, throw an extra pair of parentheses on the numerator and the denominator and let your calculator give you the whole thing. But I look at 1 minus 1/3 and I'm thinking to myself, well, that's going to be 1 plus 1/3. And 1 is the same thing as 3/3. So 3/3 plus 1/3 is 4/3. So 1/3 divided by 4/3. And all I have to do is multiply by the reciprocal. See how the 3's are going to cancel? So if you did it on the calculator, you're getting 0.25. Did you already punch it in, Brett? 0.25? Yeah. And either one is an acceptable answer. Usually, though, remember, if the problem comes with fractions, we like to see a fraction answer. But on this test, I think we get credit for both of those. Now, I am writing way too big, so this one down here. Here's the first thing that caught my eye. There's a little infinity symbol up there. So they're trying to help us out, help us see, yes, this is an infinite series here, but we might not be able to find it because it depends on what r is. So let's see. A sub n equals a sub 1 times r to the n minus 1. No matter what, r is always what's being raised to the power. So what's r? It's 2/3. It's still being raised to a power. It's not the n minus 1 power, but that's r. So there it is. Is that a fraction between 0 and 1? 2/3? Yeah, that's between 0 and 1. So we can find this. This converges. Alrighty. Now here comes the tough part with this one. There's no a sub 1 there. And this isn't n minus 1. So if we want to find it, we're going to have to put a 1 in and see what we get. Okay, 2/3 to the first power is 2/3. Well, that wasn't too hard. We already know r is 2/3. So this is 2/3 divided by 1 minus 2/3, 1/3. So 2/3 times the reciprocal, 3/1. 3's would cancel, and we get a 2. Or punch it in your calculator. Make sure you're using parentheses up here and parentheses down here, but you can absolutely punch that in and get a 2. You'll get exactly that same answer. Now, D says, will an infinite geometric series either converge or diverge? They're asking, is there another choice? So we said r between 0 and 1 converges. So the real question is, how about if r is 1? I mean, we already know if it's bigger than 1, that it's going to get bigger and bigger and bigger, and it's going to diverge. But what if r equals 1? Okay, well, let's say our first number is a 2. And we say we're going to keep multiplying by 1. How are we ever going to be able to find that? You can always add another 2. It's infinite. So it diverges. We're not going to be able to do it. So this tells us, yep, it either converges or it diverges. If it's a fraction between 0 and 1, it's going to converge. If it's 1 or bigger, then it's going to diverge. Did I spell diverging right there? Divergence. There we go. So, converge, we can find. Diverge, we can't. So that was our last objective. We had to find out that infinite series. So 4, 3, 2, 1, 0, me, how do you feel about working with s equals a sub 1 over 1 minus r? Not too bad. All right, good. Yeah, it's a pretty teeny little formula. You just have to know where to look for the good stuff to put in it. Ooh, I have to change this because I've got to get both the infinite and finite in there. So ignore what it says. Let me get you a little practice on both of these. We'll just do 8 compared to what? What's it? That way you get a little bit of the finite, you get a little bit of the infinite. That'll do it.
Odds?
Well, no. No. It's not that many to begin with. Oh, they're all formula problems.
Bill Gates' tagline of my life.